Have you ever pondered over the form of our planet? Why do we conceive it to be round and not flat? This inquiry has ignited discussions, propelled scientific revelations, and stimulated infinite hypotheses throughout mankind's history. Most of us today agree with the concept that the Earth is a sphere revolving in space, yet there are individuals who fervently uphold the idea of a flat Earth. From where this belief stems? It's a narrative that traces back thousands of years to the earliest settled societies. These civilizations, utilizing their acute observations and primitive technology, deduced that the Earth was indeed flat. However, as we are aware, thoughts transform and hypotheses are scrutinized. So, what led to the transition from a flat Earth to a spherical Earth? To comprehend this, we must traverse back in time to the inception of civilization. In ancient times, many cultures across the world believed that the Earth was flat. This notion was not confined to a specific region or civilization. It was a global belief. For example, in ancient China, people envisioned the Earth as a square, flat piece of land under a round, dome-like sky. They believed that the heavens were circular to symbolize the perfection of the celestial bodies, while the Earth was square to reflect its stability. In the ancient Near East, the Babylonians perceived the world as a flat disk floating in the ocean, with a curved firmament above where the stars and gods resided. Their cosmology was intricately tied to their religious beliefs, as they saw their gods directly influencing their world. The Norse, too, had their own flat Earth cosmology. They depicted the world as a disk surrounded by a sea, with a giant tree, Yggdrasil, at its center. This tree connected the 9 realms of the Norse cosmos, and its roots and branches reached into the heavens and the underworld. However, not all ancient cultures subscribed to this view. Some early philosophers proposed a spherical Earth. Parmenides, a pre-Socratic Greek philosopher, was one of the first to suggest that the Earth might be spherical, arguing that its shape is uniform from every angle. Later on, Pythagoras, widely recognized for his theorem in geometry, proposed that all celestial bodies, including Earth, were spherical. He believed this because spheres are the most perfect shape, and the heavens were a realm of perfection. These philosophical musings marked the beginning of a shift in understanding our world. However, their ideas were not widely accepted at the time. Most people adhered to the belief that the Earth was flat because it matched their daily observations. They saw a flat horizon and felt no curvature under their feet, which reinforced their belief. Despite these early philosophical musings, the flat Earth theory persisted. It took centuries of scientific discovery and exploration to challenge and eventually overturn this ancient belief. However, as we'll see in the next scenes, the road to our current understanding of Earth as a sphere was not a straight path. It wasn't until the Greeks and their love for astronomy that the spherical Earth theory began to take hold. In the bustling city-states of ancient Greece, a new vision of our world was taking shape, one that moved away from the flat Earth and towards a more accurate spherical representation. Pythagoras, a philosopher and mathematician from the 6th century BC, was one of the first to propose a spherical Earth. His reasoning, the sphere, in his eyes, was the most perfect shape, and so it was only fitting that our Earth should take on this form. However, Pythagoras didn't base his concept on empirical evidence. Instead, he relied on abstract reasoning and mathematical principles. Parmenides, a fellow philosopher, followed suit but with a different approach. His belief in a spherical Earth was grounded in observation. He noted that during a lunar eclipse, the Earth's shadow on the moon was always round, which would only be possible if the Earth was spherical. However, it was the 3rd century BC scholar Eratosthenes who provided the most compelling evidence for a spherical Earth. As the chief librarian at the Library of Alexandria, he was well positioned to draw upon vast resources and knowledge. Eratosthenes noticed that at noon on the summer solstice, the sun was directly overhead in the city of Syene, casting no shadow. But in Alexandria, it cast a shadow of about 7 degrees. Using this information, he calculated the Earth's circumference with remarkable accuracy. These Greek thinkers were pioneers, challenging the status quo and pushing boundaries of human understanding. Their theories, based on careful observation and logical reasoning, were revolutionary. They turned the flat world upside down, setting the spherical Earth spinning in its place. Yet, despite this groundbreaking work, the idea of a spherical Earth was not immediately accepted. Many continued to adhere to the flat Earth belief, and it would take centuries of scientific advancements and exploration to conclusively prove the Greeks were right. The Greeks set the stage for our modern understanding of Earth's shape, but the debate was far from over. During the Middle Ages, some societies reverted back to the belief in a flat Earth. This was a period marked by the rise of religious influence, where the Church's teachings often overshadowed scientific understanding. The Earth's shape was no exception. The Middle Ages saw a resurgence of the flat Earth belief, but why? Well, during this time, the Church was the primary source of knowledge and education for most people. The Church's teachings were heavily influenced by scriptures that seemed to suggest a flat Earth. Verses that spoke of the Earth's ends, or corners, were taken literally, reinforcing the belief in a flat Earth. But it wasn't just religious influence at play. During the Middle Ages, there was also a notable decline in scientific progress. The innovative thinking and scientific exploration that had characterized earlier periods, like the classical Greek era, had given way to a more cautious, conservative mindset. This lack of scientific progress meant that theories about the Earth's shape were less likely to be challenged, and the flat Earth belief was able to regain a foothold. It's important to mention that not everyone during the Middle Ages believed in a flat Earth. Some scholars, particularly those in the Islamic world, continued to uphold the idea of a spherical Earth. They preserved the works of Greek philosophers and made their own contributions to science and astronomy. Yet, their voices were often drowned out by the dominant religious narratives of the time. So, the Middle Ages saw a step back in our understanding of the Earth's shape. The flat Earth belief made a comeback, fueled by religious teachings and a lack of scientific progress. But this wasn't the end of the story. As we moved beyond the Middle Ages, a new era of discovery dawned. An era that would once again challenge the notion of a flat Earth and push the boundaries of our understanding. The Middle Ages represented a step back in our understanding of Earth's shape, but a new era of discovery was on the horizon. The Age of Exploration was a time of great scientific discovery, including further evidence for a round Earth. This was a period marked by the daring voyages of intrepid explorers, challenging the unknown and inadvertently proving the Earth's sphericity. Consider Christopher Columbus, the Italian explorer who set sail westward In 1492, under the Spanish flag, his goal was to find a new trade route to Asia, but instead, he stumbled upon the Americas. Now think about this. If the Earth was flat, Columbus would have sailed off the edge, but he didn't. He arrived at a completely different continent, proving that the Earth is not a flat plane, but a sphere. But perhaps the most compelling evidence came from Ferdinand Magellan, a Portuguese explorer. His voyage, which took place in the early 16th century, was the first to circumnavigate the globe. Magellan's fleet sailed from Spain, heading west, and continued in the same direction. After 3 long years, one of his ships, laden with weary but triumphant sailors, returned to Spain, having sailed all around the world. This feat would have been impossible on a flat Earth. The circumnavigation was concrete proof of our planet's roundness. Moreover, the age of exploration saw the development of advanced navigation techniques. Mariners began to understand and use the concept of latitude and longitude. These coordinates, based on angles measured from the Earth's core, allowed sailors to pinpoint their exact location on the globe. This wouldn't work on a flat surface, further reinforcing the idea of a round Earth. By the end of the age of exploration, the round Earth theory was widely accepted among educated people. The voyages of Columbus and Magellan, along with the advent of sophisticated navigational methods, had provided empirical evidence that the Earth is indeed round. It's quite astonishing how exploration and scientific discovery can reshape our understanding of the world, isn't it? In the modern era, we have numerous pieces of evidence that confirm Earth's round shape. Perhaps the most compelling of these is the wealth of images and videos captured from outer space. Our astronauts and space probes have sent back stunning vistas of our blue planet, clearly showing its round shape. The iconic blue marble image taken by the crew of Apollo 17 in 1972, for instance, leaves no room for doubt. Yet, the round Earth doesn't just reveal itself in photographs. Satellite data too corroborates the spherical model. Satellites, by design, operate under the principle that Earth is a sphere. Their paths around our planet, known as orbits, are determined by the gravitational pull of our round Earth. If Earth were flat, these satellites wouldn't be able to orbit as they do. Furthermore, the Global Positioning System, or GPS as it's more commonly known, also functions on the assumption of a spherical Earth. The system, which relies on a network of satellites, uses the time it takes for signals to travel from the satellites to a GPS receiver to calculate distances. This only works because the signals follow the curvature of the Earth, something that wouldn't be possible if our planet were flat. Then, of course, we have the principles of physics, which are grounded in the reality of a round Earth. Take gravity, for example. It pulls everything towards the center of mass, which, in the case of a spherical Earth, is at its core. This force of attraction not only keeps us grounded, but also shapes the planet into a sphere. If Earth were flat, gravity would act differently, and we'd notice. Even simple observations we can make without any special equipment point to a round Earth. Ever watched a ship sail away towards the horizon? You'll notice that it doesn't just get smaller and disappear. Instead, it seems to sink, starting from the hull, and eventually leaving only the top of the mast visible. This phenomenon, known as ship's disappearing hull first, is a direct consequence of Earth's curvature. In a similar vein, consider lunar eclipses. When the Earth passes between the sun and the moon, it casts a shadow on the moon. This shadow is always round. Regardless of the time or location of the eclipse, the round shadow can only be explained if the object casting it, Earth, is spherical. In the face of such compelling evidence, it's difficult to understand why anyone would believe otherwise. But, as we'll see in the next scene, belief isn't always a simple matter of accepting facts. In the realm of human thought, even the most blatant truths can be questioned, and the most outlandish ideas can find fertile ground. Despite this overwhelming evidence, the flat Earth theory has seen a recent resurgence. In the 21st century, the flat Earth theory has made a surprising comeback. Yes, you heard it right. Despite centuries of scientific advancement and confirmation of the Earth's spherical shape, the flat Earth theory has found new life in the digital age. Let's delve into this resurgence. The internet, with its vast reach and ease of access, has played a significant role in this unexpected revival. Social media platforms in particular have become a breeding ground for misinformation and conspiracy theories, including the belief in a flat Earth. In these virtual spaces, anyone can voice their opinions, regardless of their scientific validity. This free-for-all dialogue allows for the rapid spread of ideas, and unfortunately, the propagation of misinformation as well. Adding fuel to the fire are celebrity endorsements. When someone with a large following vocalizes support for a fringe theory, it gains a certain level of credibility in the eyes of their fans. Even if the endorsement is made in jest or without a full understanding of the theory, it can lead to a surge in its popularity. This is exactly what has happened with the flat Earth theory. Several high-profile celebrities have publicly questioned the Earth's roundness, inadvertently promoting the flat Earth theory to millions of followers. However, such endorsements and the spread of misinformation on social media don't change the scientific consensus. The Earth is spherical, a fact that has been proven time and again over the centuries. But the resurgence of the flat Earth theory is a testament to the power of the internet and the influence of popular culture. It underscores the importance of scientific literacy and critical thinking in the digital age, where misinformation is just a click away. And yet, despite all the evidence to the contrary, the flat Earth theory remains a controversial topic, a testament to the power of belief and the allure of conspiracy theories. The flat Earth theory remains a controversial topic, despite the scientific consensus. Why do people continue to believe in a flat Earth, despite the evidence? This question leads us to the fascinating realm of the human psyche. The psychology behind belief is a complex web of cognitive biases, distrust in authorities, and the allure of conspiracy theories. Let's start with cognitive biases. These are systematic errors in thinking that affect the decisions and judgments that people make. One of these biases is confirmation bias, where people tend to favor information that confirms their existing beliefs and ignore information that contradicts them. In the context of the flat Earth belief, people with this bias would be more likely to accept data that supports the idea of a flat Earth and disregard anything that proves otherwise. Now, let's move on to distrust in authorities. This is another significant factor that fuels the belief in a flat Earth. We live in an era where information is at our fingertips, but so is misinformation. Additionally, There have been instances where authorities have been caught lying, leading to a widespread distrust. When trust in authorities wanes, people start questioning everything, including established scientific facts. This skepticism can make the flat earth theory seem more plausible to some. But what about the allure of conspiracy theories? Conspiracy theories can be incredibly enticing. They offer an alternative explanation, often involving powerful figures or organizations pulling the strings behind the scenes. Believing in a conspiracy theory can give individuals a sense of superiority, as they feel they've uncovered a hidden truth that others are blind to. The flat earth theory, with its claim that governments and scientists are hiding the real shape of the earth, fits snugly into the framework of a conspiracy theory. Furthermore, we cannot underestimate the role of the internet and social media in the spread of these beliefs. They provide a platform where like-minded individuals can connect, share ideas, and reinforce each other's beliefs. This creates echo chambers where the flat earth theory and similar ideas can thrive. However, it's crucial to note that belief is not a sign of stupidity or ignorance. It's a testament to the power of the human mind to weave narratives and seek patterns, even in the face of contradicting evidence. This is a trait that has helped us survive and thrive as a species. Understanding why people believe in a flat earth can help us address misinformation and promote scientific literacy. To tackle the spread of such beliefs, we need to foster critical thinking and provide reliable information. We need to build trust in science and scientists and show that questioning is a crucial part of the scientific process. But to question effectively, we also need to understand how our minds work and how our beliefs are formed. This understanding is the first step towards a world where scientific literacy is the norm rather than the exception. In a world filled with misinformation, critical thinking is more important than ever. We live in a time where access to information is at our fingertips. However, this wealth of knowledge comes with a challenge. Not all information is created equal. Some of it is based on rigorous scientific research, some is conjecture, and some is outright falsehood. This is where the power of critical thinking comes into play. Critical thinking isn't just about being skeptical, it's about being curious. It's about asking questions, seeking evidence, and not being afraid to challenge established notions. Remember, every scientific breakthrough began with a question, a doubt, a curiosity. When faced with a claim, whether it's about the shape of the earth, the efficacy of a medical treatment, or the causes of climate change, it's vital to ask, where is the evidence? Who's making this claim, and what's their motive? Is this claim based on rigorous scientific research, or is it just an opinion dressed up as fact? Scientific literacy, the understanding of scientific concepts and processes, is crucial in today's society. It helps us make informed decisions about our health, our environment, and our future. It allows us to discern between reliable science and pseudoscience, between fact and fiction. Encourage curiosity in yourself and others. Question information. Seek evidence. Keep learning. Remember, knowledge isn't a destination, it's a journey. The more we learn, the more we realize how much there is yet to discover. In a society that is increasingly dependent on science and technology, being scientifically literate and a critical thinker is not just a personal asset, it's a necessity. It's the key to navigating this complex world, making informed decisions, and debunking myths and misinformation. Whether the earth is round or flat may seem like a settled question, but the debate serves as a reminder of the importance of critical thinking and scientific inquiry. Because in the end, it's not just about knowing the right answers, it's about asking the right questions. Thank you for joining us on this thought-provoking journey through ancient beliefs, scientific discovery, and the human psyche. As we've seen, the shape of the earth is more than just a physical fact. It's a testament to the power of scientific inquiry and critical thinking. It's a reminder that truth isn't always what it first appears, and that to find it, we must be willing to question, to explore, and to learn. But our journey doesn't end here. There are countless other mysteries to unravel, truths to uncover, and myths to debunk. As we continue to explore our world and the universe beyond, we invite you to come along, to question, to learn, to think critically. Because knowledge isn't just power, it's the key to understanding our world and our place in it. So, if you enjoyed this journey through belief and truth, don't forget to like and subscribe for more enlightening content. And remember, the power of knowledge is in your hands. Use it wisely. Until next time, keep exploring, keep questioning, and most importantly, keep learning. Because in the end, knowledge is power.